Now for question number 2, I will consider this question as a moderate level of difficulty question, but if you are not careful and if you will not write all the possible cases, then there are higher chances that you will commit big mistake in this question. Okay. Now there are some constraints that you need to take care about. First of all, it's a two-digit number less than 85, such that the sum of the squares of its digits ends with 5. Okay. Now the number has to be a two-digit number. It has to be less than 85, and the sum of the squares of the digits should end with 5. Now, first of all, we'll make all the possible cases in which this can happen. Okay. Now, I want the sum of the squares of the digits to end with 5. Now, first of all, I can write, or I will write all the ways of obtaining the unit digit of any perfect square. So a perfect square can end with either 0, 1, it cannot end with 2 or 3, it can end with 4, 5, 6, it cannot end with 7 or 8, and lastly it can end with 9. Now if I want the sum of the squares of the digits to end with 5, so there can be different possibilities. Case number 1, it can be the unit digit can be 5 and 0. So 5 plus 0, the unit digit will be equal to 5. Okay. Now the second possibility can be, it can be 1 plus 4 or 4 plus 1. Okay. I'll write both of them, or 4 plus 1. In the first case, I have not written 0 plus 5 because 0, 5 will not be a two-digit number. Okay, fine. So 5 will come first. 5 will be the units digit of the digit at tens place, and then 0 will be at the units place. The third way it can be possible is 6 plus 9 or 9 plus 6. Alright, so these are different possibilities. Now, first of all, let us write all the cases. Now, here the number can be 5, 0, 50. Okay, so 50 is a number such that the sum of the squares of the digits will end with 5. Now, the square ends with 1. So what are the numbers whose squares end with 1? So it can be either 1 or it can be 9, right? So tens place can be either 1 or 9. Correspondingly, units place should be a digit such that its square ends with 4. So 2's square ends with 4 and 8 square ends with 4. Okay, so tens place can be either 1 or 9 whose square will end with 1. Units place can be either 2 or 8 such that the square will end with 4. Okay, now what all numbers I can form using these? So the numbers can be 12, 18, 92, 98. Now, out of this, 92 and 98 will be rejected because they are greater than 85. I want my number to be less than 85. Okay. So, from here, I can pick up two possibilities. Now, the next is 4 plus 1. So, I need a digit whose square ends with 4. Alright. So, it can be either 2 or 8. And for the units place, it can be either 1 or 9. So, I've just reversed the previous case. So, the numbers that can be formed will be 21, 29, 81 or 89, right? Out of these, 21, 29 and 81 will be selected and 89 will be rejected. Okay, so earlier two numbers 92 and 98 were rejected and then 89 was rejected, right? Now moving on to third case, I need a number whose square ends with 6. So the number is 6, all right? So 6 square ends with 6 or 4 square ends with 6, right? Similarly, the number whose square ends with 9 will be either 3 or 7. Okay, so here the possibilities can be 63, 67, 43, 47, right? So these are four possibilities. Similarly, for next, the tens place can be either 3 or 7, units place can be either 6 or 4. So the possibilities will be 36, 34, 76, 74, right? So let's count the total number of possibilities. So these four cases will be counted, right? Wait, I'll quickly change the color of the pen. So these four cases will be counted. They are valid. These four cases, all of them are less than 85 will be counted. Then these three cases will be counted. These two cases and finally this one case. So 4 plus 4, 8 and 3, 11 and 3, 14. So the answer of this question should be equal to 14. So there are 14 two-digit numbers which are less than 85 such that the sum of the squares of its digits will end with 5 and 14 is the correct answer. So that was question number 2. Slightly complex because we need to consider all the possible cases, but I will not consider it a very difficult question. Let's move on to question number 3.